This puzzle's called Electrical Infetterence by MicroStudy. I got it from the CTC community Discord, the Sudoku testing submissions channel. Let's take a look at the rules. So we have normal Sudoku rules, of course. We have German whispers. So digits along the green lines must differ by at least 5. So if we had a 3 here, let's say, then this would have to be an 8 or a 9, since those are the only digits that are 5 or more away from it. Digits can repeat, so if this was like we could have a 9 up here and then a 9 down here, let's say, that would be just fine. Of course, you can't repeat within a box or within a row or column, but the line itself doesn't mean you can't repeat. Palindrome lines, digits along a gray line must read the same forward and backwards, so these two digits are going to be the same, and these two digits are going to be the same. Same with this gray line over here. Can be read the same backwards and forwards, so these two are the same, and these two are the same. Then the thermo, digits along the thermo must increase away from the bulb, which is the circle. So if this was a 3, this would have to be less than a 3, this would have to be greater than a 3. This would have to be something like that. And of course, that would be the case for every, segment along there. I don't know how hard this puzzle is. Like, it was literally just posted like 12 minutes ago. So, I'll put a link to the puzzles down in the description if you want to give them a try yourself. Let's get going. So the first thing I see is to, I do this, so I'm going to type in all the options on this. Since there's only 3 options, I will do that and see what I can see if there's any limitations. I don't think there's anything. The next thing is probably the longer German whisper lines. This one up in the top left and this one in the bottom right. So there's 2 kind of tricks with German whispers that go together that we should probably go over first. So the first is that 5 cannot appear on a German whisper. So if we tried to put a 5 here, we need a digit that's at least 5 away. Or 5, the difference is at least 5. So we'd have to do a 0 or a 10 or something like that. Obviously that doesn't work. So 5s can't go on the German whispers. Now, the next thing is kind of related to that, is that the digits along a German whisper kind of oscillate back and forth between being less than 5 and then being greater than 5, and then obviously just repeating that. So if we have, let's say, a 2 here, 2 is less than 5, so the next digit is going to be greater than 5. In fact, it's going to be 7, 8, or 9. Now it has to be less than 5 again, so even if this was all the way at maximum digit, we still are going to have, 1, 2, whoops, we're still going to have 1, 2, 3, or 4, which is again less than 5, and then even if we do 1, we're going to, go all the way back up above 5 again to be 6, 7, or 8, because we've already had the 9. So we have this kind of, oscillating effect here, so these digits will all be either all greater than 5 or all less than 5, and similarly, yellow will be the opposite of that. So we do know this other line will do the same thing, but we do not know if it is greater than or less than. Sorry, we don't know if the yellows would match up. So we don't know that these are both greater than or both less than. It would be totally independent. So we could do like blue and dark green or something. And we don't know if blue is the same as yellow or blue is the same as pink. It's one of the two, but we don't know which. Well, here's one small thing. Let's delete these colors. I didn't think to look here first, but I think this might be the right place. So 6, 7, 8, and 9 are obviously greater than 5. So both of these are going to be greater than 5 on the thermometer. Now we have a German whisper line, and we don't know exactly how it's going to be arranged, but something like this. Either yellow is going to be both greater than 5 or both less than 5. Same with pink. So we're going to have 2 greater than 5s, and then one of these 2 colors is going to be another pair of digits greater than 5. So that's all the digits greater than 5 in this box. That means these digits are all less than 5 or 5 itself. And I don't really know how that helps. We can copy that here because of the palindrome line. Guess we know one of these is a 5. Okay, yeah, okay, so we know one of these is a 5, which means this can't be a 5. If this is a 5, then these two can't be 5, which means this is a 5, and then this would be a 5 as well. Because of the palindrome. So that's not going to work. This cell can't be a 5, which means this is not a 6, this is not a 7. So this is another guaranteed high digit. I'm just trying to think of what that does, if anything. Okay, here's something. We need a 6 in here. We haven't put a 6 in here. So it's going to be one of the high digits. We don't know if it's pink or if it's yellow, but it's one of those two, obviously. The 6 must be on the end. If we try to put a 6, let's say here, then the only digit that's 5 away from it is 1. So we need to put 1 in both of those cells. Obviously, you can't have two 1s in the grid, or in the same box. So one of these is going to be a 6. And then connected to that is going to be a 1. We don't know which is going to be the one, but one of them is going to be the one, which is going to remove 1 from everywhere else. And then the next cell along there. So if this was 6, this is 1, then this could basically be anything. I mean, it would be 7, 8, or 9, but yeah. And it would basically be dictated by what's in here. I don't know if this is the way I'm supposed to be going about this, but this does seem to be giving me some information. Looking over here, we can't quite do the same thing because these two are going to be the same, high or lowness. But this cell over here, the green cell, is also, we don't know the higher lowness, but these could be the 3 low digits, which would allow us to have, some degrees of freedom here in terms of low digits. We can't, we can't guarantee to have, all the high digits, or sorry, all the low digits accounted for over here, like the same way we have all the high digits accounted for over here. There might be a way, but I'm not seeing it right away. Let's just get rid of those colors for the moment, since we don't have a ton of different colors. Okay, so we do need a lot of high digits here. Where could we put a 9 in this box? I'm just trying to think of, what happens. If we put a 9 here, that means this isn't a 9. If we put a 9 here, that means this isn't a 9. And if we put a 9 here, that means this isn't a 9. Because if this is a 9, it directly sees it. If this is a 9, it goes here along the palindrome and sees that, and likewise, this goes along the palindrome and sees that. But that still leaves these two spots. Now this, of course, sees it, but this could be a 9 and not see it. So we've almost restricted it. And probably 1 will work the same way as, 1 will probably work similarly. Where can we can put 1 in one of these cells. Let's just highlight these blue for the moment. If either of these are 1, obviously this cell can't be 1. If this is 1, then we put a 1 here. This can't be 1. If we put a 1 here, this becomes a 1 and this can't be a 1. But if we put a 1 here, does that do anything? If we could rule out 1 from the beginning of the thermometer, then everything, or at least the first 4 cells, would be pushed up a little bit, which would be somewhat important. Okay. Well, I guess I could ask. So I was all on the right track, I think, but I didn't quite ask the right follow-up question. So the possible spots for 9 and 8 are in blue. Both 9 and 8 have to be in blue. And we said that all of these cells all of the, let's say, dark blue cells see this cell. So if we put it, I said this before, if we put a 9 here, this becomes a 9, and this becomes an 8. If this is a 9, then this is a 9, and this becomes an 8. But that same exact thing holds true for 8. If we put an 8 here, this becomes an 8, and this becomes a 9. If we put an 8 here, this becomes an 8, and this becomes a 9. Therefore, I don't think we can have both 8 and 9 in dark blue. If we tried to make this an 8, and this a 9, this would become an 8, this would become a 9, and suddenly this doesn't have a value anymore. Because if we do, obviously we do 8, that's broken. If we do 9, that's broken. Which means one of 8 or 9 must be in light blue. Which is actually somewhat large. Let's get rid of that. Or, yeah, let's just get rid of that color for the moment. So that means these digits must be high digits. And these digits must be low digits. And then there is an 8 or a 9 lurking somewhere else, but that doesn't matter as much. This is 6, 7, 8, or 9. This can't be a 6, because if this was a 6, that would mean both of these are 1s. This can't be a 6, because that would mean both of these are 1s. So these are just 1, 2, 3, 4. Does that matter? Is there any way we can narrow that down a little bit? I guess this can't be a 4, because I would put 9 in both of these cells, because 9 is the only digit with a difference of 5 with 4. 5 or greater, I guess. So that is progress. Can we do the same thing over here? It's making me think that there's going to be like a similar thing we can do over here. Although this could be a 2. No, but if this is a 2, then this is a 2, and then this can't be a 2. It is making me think that there's going to be a similar pattern on this side. Obviously not there. For 1s, maybe 1s, 2s, and 3s? Where we have to hide one of them up here. So what digits? Yeah, so these are the cells that can be 1, 2, or 3. Right? And if we tried to place them, obviously in the same row, or here, or here, or here, yeah, we need to, in the dark and light blue cells, we need to fit 1, 2, and 3. But if we put all 3 of 1, 2, and 3 into dark blue, let's say 1, 2, and 3 like this, then this becomes a 2, this becomes a 1, and what do we put here? This can't be a 1, or a 2, or a 3. And no matter how we arrange these, 1, 2, 3 like this even, this becomes a 1, this becomes a 2, this becomes a 3. I guess that last one didn't matter. And suddenly this cell can't be a 1, can't be a 2, and it can't be a 3. Which means we have to hide one of them here. We don't know which one, but we have to hide one of them away so it can't see this cell. In fact, these two cells must be the same thing. So I kind of want to mark that. Similarly, these two cells must be the same. Make it light pink. Which then gives us the high-lowness of these cells over here. So this is a 1, 2, 3, 4. This is a 6, 7, 8, 9. This can't be a 6. This can't be a 4. This can't be a 4. I guess let's just start coloring more cells because that will be important. We don't know which is which over here. We know both of these are 1 and both of these are the other, but we don't know which is which, right? This is very strange. I'm really liking this puzzle, but this is very, like, mind-bendy about, like, how how this is working. I feel like this must be intentional. I'm not going, maybe I'm going crazy, but I do feel like this is intentional. The way that so much stuff is just lining up. Yeah. It's very, very well made, but it is also, yeah, breaking my head a little bit. Because there's also this whole, like, thermoness that I haven't even, like, really considered. Have I really? Is there anything I can do with that? It's like this is a 3. This is 4, 5, 6, 7, 8, 9. Does that break anything necessarily? This could still be a 2. This is a 3. That does that break stuff? That would be 2, 2 here. This would need a 3 in green. I don't think that's a problem. Oh, that does break the puzzle. I don't know if I necessarily want to care about that, but all the way down here, the puzzle does get broken. Because we need a 3 in green, and then the 2 high digits, so this would have to be 1 and 3 like this, and then this would be a 7. And we can't have a 3 next to a 7. Yeah, I will record that, because I might as well. It's not super complicated, it's just like following up the thermometer, but I don't think that's necessarily where I was supposed to look. Interestingly, whatever light blue is going to be in here. Maybe that's where I was supposed to look. I just happened to notice one specific case of that. Whatever light blue is going to end up in green, because it cannot be a 7 or an 8. Obviously 1 and 2 is not 7 or 8. So these must be low digits. These must be the high digits. So this is a 6. This is a 1. Now this could be light blue. 1 could be light blue. We don't know. And this is a 7, 8, or 9. I guess we know pink is over here as well. But because this isn't an N, this could be pink and still have this be a low digit. So let's say this... trying to figure out... because if these were both highs, that would be all the high digits here in the row. And then this would be a high digit. These would both be low digits. That would be a high digit. So we need 2 more high digits, which would have to be these 2. Which would make this a high digit. I don't know, I don't see anything. I think I'm just grasping at straws here. Doesn't seem to be broken. Maybe it's this little N duder again? It was surprisingly helpful at the start. You know what, I want to change these dark blues. I'm going to change them to dark yellow. I think that dark blue is a little hard to see for me, so I'm going to change it up. So this digit is anything but 4, 5, or 6, or 7. It can't be 7 either, because a 7 would require 1 and 2 digits next to it. And then that would be obviously 3 1s and 2s. So this can be anything except for 4, 5, 6, 7. For whatever little that helps. Whatever little that helps, that is the case. If this is a low digit, then we do have a triple on low digits. And I don't know if this helps, but if these are high digits, then that would be all the high digits in the row. And one of them would have to be a 6, so this would have to be a 1. I don't see that that's... which would mean that this would have to be 6, 7, and this would have to be 8, 9, because we couldn't have a 7 over here, because it would require a 1 and a 2. No, I guess this could be a 7 with this being a 2 and this being a 1, never mind. So this is just 6 in some high digit. If these were high, which is already, a 50-50 assumption at best. If this is a high digit, this is a 7, 8, or a 9, which would be 7, 8, or 9 there. Is that a problem? So let me look at this. Let's make it hot. Whoops, not gray. Let's make it hot pink. Let's make it green. Okay. So if this was a high digit, it couldn't be light pink, obviously. And it couldn't be this one, and it couldn't be 6 itself. So these two, if green is a high digit, then it would have to be this digit. Is that a problem in any way? In any shape, way, or form? That would put him out over here. But again, we looked at that a little bit, and that didn't seem like an immediate problem. What if green was a low digit? If green is a low digit, what's the problem? This is a 2, 3, or 4. That doesn't seem to really matter at all. Okay. If these are high digits, it's actually very restricted. I didn't notice this before. If dark green now, this new dark green is a high digit, it sees 3 different high digits because it sees the 3 along the thermometer, which means that it's the 4th high digit. Which I guess means that this wouldn't be a 6. This couldn't be a 6 because that would be a 4th high digit that it would see. I don't see how we could make use of this or prove it wrong. But this does seem to be true, that this would see all 3 of these high digits. And these two, I think, is less helpful because it doesn't even see this. Oops, does this see maybe a bunch of low digits that I'm not realizing? It does see these first 3 digits. Actually, I mean, it sees... It actually sees all the digits along the thermometer, doesn't it? Let me just double check. So sees this one, sees this one, sees this one, this one, this one. So dark green here is not on the thermometer, and I'm gonna bet that this digit is also not on the thermometer. Let's make it light green. Light green and dark green are not on the thermometer anywhere. This one sees here, those obviously, yeah. So dark green, light green are different as well because they're both in box 5. Which means the thermometer plus dark green plus light green is a set of the digits 1 to 9. That's very strange. That's very strange. That is very strange. I don't know what else to say besides that is very strange. Okay. Oh, the better way to look at this. Okay, now that I'm thinking, rather than looking at this more randomly like I was just trying to pick out spots on palindromes, where does dark green go in box 6? Dark green is not light green. Therefore, it is 6 or 7, 8, 9. Therefore, this is a high digit. So I'll just make them a little bit Christmassy here and still mark them green, but they'll be high digits as well, which means these can't be high digits. If these were high digits, we would have 5 high digits in the row. So these are low digits, which makes this a high digit. So this is not 1, 2, or 3. So these are low digits, 1, 2, 3, 4, which means we have all the low digits and the 5. One of these... Ooh. We don't actually know that I was going to say one of these has to be a 5, but we don't actually know that that's the case. Oh, yes, we do. Yes, we do. Because, yeah, we have 5 digits that are low or 5, which means those... Yeah, one of these is a 5. Therefore, this is not 5. Therefore, 5 is on the thermometer, for whatever that's worth. And therefore, these are high digits as well. This is... like, so... I don't know what the word is. intricate, maybe, where the yeah, the clues are just like, they didn't look that. I mean, obviously it looks like I don't know, lightning bolts or whatever, but they're all so like just affecting each other in just the right way. It's very well made. So this is a 6, 7, 8, or 9, right? I mean, that's just the definition of a high digit. I don't think I'm making any brilliant deduction there, I suppose. Oh, these must be low digits, so I can mark those as low. So we actually have the 4 high digits in the middle, so this must be a low digit, so this must be a low digit. One of these is a low or a 5, and this is a low or a 5 as well. I used gray. Maybe I shouldn't use gray for 5 because we have these gray lines, but I'm going to for right now at least. This must be a high digit, I believe, because no, this is a wait. 1, 2, 3, 4, 5. This must be a 5, actually, because we only have 3 high digits. So this is a high digit, which means, and I guess we could have looked at it this way. We had 5 cells that could be a low digit or a 5, and literally only one of them could have been a 5. So therefore, that cell must be the 5. So this is a 4. This is not a 4, because it must be less than that. So one of these is a 5 or a high digit. Well, one of them's a 5 and one of them's a high digit, I guess I should say. We don't know which one is light pink. I don't even know if I need to keep marking these because I'm getting kind of overwhelmed with all the different colors. So this is just 2, 3, 4. One of these is a 2. Yeah, we have a 2, 3, 4. Oh, I guess this is the easier way to do it. We have a 2, 3, 4 triple here. This must be a 1. And we have light blue here, so these are both 1s. Let's just change that color now. Yeah. 2, 3, 4, and then this is the other of 2, 3, 4. Which means this digit is this digit, which is this digit, which is up here somewhere. Wait, that's... Okay, maybe I do need to color these still. So this is... Let's look at the 2, 3, 4. So green, these 2 light green ones are definitely the same. These 2 light blue ones are definitely the same because they're on the palindrome. This one is not light green or light blue. So let's do hot pink, I guess. Or let's do black for the moment, because hot pink kind of looks like dark pink. So black is a 2, 3, 4 that is not blue and is not green. What can this one be? It can't be black because it has to be less than black. It can't be green because it sees green. Therefore, this one is blue. Now this one can't be blue, can't be green, must be black, which means it must be a 3 or a 4 to match this. And also this one can't be 4 because this one can't be 4. So one of these is blue, and the other one, light blue, and the other one is the 5. These can't be 1 anymore, I guess. So this is green and black. We don't know which is which. Oh, this can't be a 1. This can't be a 6 then. This could still be a 6 if we put 1s on both sides. Okay. Is there anything more I can do with this coloring, or can I get rid of these colors maybe? Let's just get rid of them. Oh, blue. This can't be a 4 up here because this is blue, light blue, or it's gray. So it's a 2, 3 if it's blue. It's a gray if it's 5. Yeah. So this is not blue, and we don't need to mark this anymore, I don't think, and probably don't need to mark this anymore. At least for the moment. I don't know if that's helpful to mark. One of these is a 6. If this is a 6, this is a 6. I think that's fine. I mean, that would force 6 off the line, but that doesn't really matter. Oh, it does make sense. Now that I'm thinking about it, it does make sense that this has to be 5, because we said the thermometer plus these two, plus this digit, plus this digit. Let me just highlight this. This is a complete set of the digits 1 to 9. Because this is a high digit and this is a low digit, we need 3 highs and 3 lows on the thermometer, therefore 5 must be, bang in the middle. I think that seems reasonable, at least. Where can 5 go in this column? 5 must go down here. One of these is a high digit, one of them is a low digit. We don't know which is which, but that'll be all the high digits in the column. So this will be 1, 2, 3, 4, 5. That's not all that nice to look at. 5 options along here. I guess that's almost all of these. If we could rule out 5, that would be nice. So what is this? Well, this is 7 or 8. This is the same as this, because it can't be. So there are 4 or 5. There are 4 high digits. It's basically the same thing we were doing with the 2, 3, 4s, except we don't know which one is 9. But that's fine. So this digit is different than these digits, because this digit is also this digit. This is a set of the digits 6, 7, 8, and 9. So what digit is this? It can't be this extra digit, so it must be a digit that's all on the thermometers, and it can't be either of these two. Therefore, this digit is this digit. This is 7 or 8. And it is, in fact, this same as digit. I don't know if we can learn anything from that. I mean, I guess it's this one down here, so this can't be a 9 down here. Right? This is, yeah, we don't even need to know this one over here. Just these two digits are the same. Therefore, it's going to go in row 6 in box 4, which is going to be in one of these cells. It's going to be whatever color we wanted to make this, but we're not making it a color. It's going to be this digit, or it's going to be a 5. The same way this was like light blue, I think, or a 5. This is the 7, 8, or a 5. Okay. So one of these is a 6. This digit is not on the line. That's fine if it's a 6, so we could still do 7, 8, 9. What digit is this? Because it's not the extra digit, so it must be a digit that's on the line. So it's this digit or this digit. Okay, that's not helpful. If this digit was pink, that would mean this. What could this digit be then? I think this has to be. Okay, let me go through that. If this is pink, let's assume this is light pink, actually, specifically light pink. If this is light pink, what digit could this be? I think this must be light pink. Because let's just say this is light pink. This would have yeah, this would be an 8-9 pair. I guess that's the best way to look at it. This would be an 8-9 pair. This is a 7, which is kind of what we expected with this. Whoops. Took off the wrong digit. But then this is a 6. And now this can't be a 6 or a 7. This must be the light pink, which means this is this digit. And this is 6 or 7. Oh, let's just take off that for the moment. This digit is the same as this digit because it must be on the line because it sees this digit, which is this digit, which is the 4th of the set. And this is the 4th of the set, which we know nothing about except that it is a high digit. We know this digit is this digit. This digit is not on the line. I was just seeing if we could figure out what this digit is or something like that, but I don't think we can. Why is this light? How did that become blue? Did I must have just accidentally typed it, or has it been light blue for this whole time and I just didn't realize? Yeah. Okay, one of these is a 4. I should have noticed this a while ago. One of these is a 4, therefore this is a 9. Which means light pink is 9, and we no longer need light pink. It can join its brethren as just being dark pink. Which means this can't be a 4, this is a 3 now. Which makes this an 8. Oh, when I took 2 as an option... When I took off 2 as an option, I remember thinking that this couldn't be a 7 anymore, but I didn't actually mark it down. Progress. So much progress. This must be a 4, this must be a 2. These can't be 2s or 4s. This is a 1-3 pair, so this can't be a 7. This can't be a 9, but it could. This one still could be 7 if this is 1. This is a 7. Let's just go back to Sudoku. This was... I mean, I'm obviously not done with the puzzle, but this was awesome. I'm really enjoying this puzzle. I picked up this puzzle thinking it was going to be kind of easy. Why did I say that couldn't be a 6? Can't be 7 or 8. I picked up this puzzle thinking it was going to be kind of easy, not really for any reason. It just seemed like there was a lot of clues. And I was mistaken, but pleasantly mistaken, because this has not been easy at all, but also been a lot of fun, and just like very, very beautiful, beautifully made. All these clues have just interacted in such a weird way. I've obviously, yeah, very much enjoying this. This can't be a 3 or a 2. It can't be a 4 because that would put a 9 here, so this is a 1. Which makes this an 8, 9 like that. Well, that can't be a 1. Or 3. I guess there's literally a 3 right there. What am I doing? Okay, so there's a 9 up here. That doesn't help, unfortunately, because 9 can go with any low digit. Yeah, if we could have forced a 6 up here, like the way we did over here, we could have put a 1 on the line at least, but no luck. This could be a 2 or a 3. Let's double check. I think that's all that we have. Yeah, okay. Is it time for Sudoku, or 3 is along here, 9 is no, 9 is in one of these two, 8 is in one of these two, 6 is in one of these, 8 is one of these, 9 is in one of these. At least we're getting stuff that's touching a line now. That's a little bit better than just kind of floating in the middle of nowhere. Oh, one of these is the 6, because this 6 is looking up. One of these is the 6, so we have 6s looking over. One of these is a 6. Unfortunately, we don't seem to have that same thing going on with this down here. Did I do 8? Yeah, I did 8s. 1s? 1 is actually right here. There we go. That is some fancy, or not fancy, that's some helpful Sudoku. I don't know why I said the word fancy. So this is a high digit, so this is a 7 or a 9. This is a 2, 3, or 4. I don't think we know anything more about it. Yeah, it could be a 4, 9. That would work just fine. Okay, do we know anything about this? I don't think we do. Okay. This digit is a low digit or a 5. So it's a 2, 4, or 5. It's a low digit or a 5. Because it sees 6, 7... Sorry, yeah, 6, 7, 8, 9. Is there something more we can figure about? If this is a 7, this is a 2. Makes this a 3. Is that a problem in any way? 7, 7 makes this a 7. It's a 5. Is that a... That puts 5 up here? Is that bad in some way? I don't see why. Oh, this can't be a 1 any longer. Ooh. This is a 1-9 pair. How did I not see that before? This is just a 1-9 pair. Which unfortunately... Actually, no. Not unfortunately. This is a 9-1 like this. I'm just slacking on basic Sudoku, I guess. I thought I was doing pretty well at it there for a bit, but oh, that just resolved a whole bunch of little bits there. Let's mark that before we go on. So this is a 7th, this must be a 2. Um, 7, 7 is right here. That's all the high digits up there. 6, we can't tell. 8 is in one of these two. I guess all of these are low digits. Oh, this must be the 5. Because it sees 1, 2, 3, 4. So this must be a 5. Which makes this a 5. Which, interestingly, I know this is dumb, doesn't really matter. I said this was a 5 and had to remove the 2 digit there from there, and then press the 2 button to make it gray. And then it's just weird that the 2s and 5s are 2 and 5 of the colors. It doesn't matter. I'm talking nonsense now. But it's just a weird coincidence. This is 2, 3, 4. One of them's a 3, and they're both low. Actually, they can't be 2. There's 2s right there. What am I talking about? This is a 5 then. This is a 6 then. I don't know if you could just hear one family member yelling that they have to go to the bathroom. That's great thing to yell right outside my door while I'm recording. I already said 8 had to be there. Oh, where can 4 go in box 2? That's just a 4, which makes that the 8. 3 and 5. Yeah, you can never really guarantee that family members will cooperate. Whoops. During the holidays for your recording. This is a 5. This is a 2 or a 3. This is a 6 or a 4. Whoops, wrong buttons there. 6 or a 4. Don't know anything about either, unfortunately. Oh wait, no, we have a 2, 3, 4 triple there, so this is a 6, 4. Okay, let's look right here. This is a 9 and a 7, 9, 7. Which makes this a 4, 7. Which makes this the 9. That doesn't force a 4, and in fact it can't be a 4 because of this 4 right here. We have no, we don't know where the 7 is. 7 is just down here somewhere. This can't be a 5, this can't be a 4. What are these 3 digits? These are 3, 8, and 6. 3, 8, and 6. This can't be a 6. This can't be a 3, this can't be an 8. Okay, that didn't help that much. Okay, there's probably just some Sudoku I'm missing. Okay, so what's here? This is 3, 5, 6, and 7. This can't be 5 or 6. This can't be 7. This can't be 7 or 3. Oh, okay. Where can we put a 4 in this row? Is that the best way to show this? Yeah, or I guess I could say, where can I put 4 in box 7? We have this 2, 3, 4 triple. Oh, no, it's not a 2, 3, 4 triple. It's just a 2, 3 pair with... I'm silly. I wonder how long that's just been sitting like that. Making it a little bit hard on myself. It wouldn't be a puzzle solved with me if I wasn't making it harder on myself. This can't be a 5 then. Okay, so now where can 4 go? This must be a 4, which makes this a 7. Makes this a 5 and a 7. And that's going to resolve everything. This must be the 5, and this must be the 8. And there we go. Let's just double check. Yeah, so here's the fully colored grid, but let's just double check these lines because I want to make sure. 1, 9, 2, that looks like it works. That looks like it works. 8 to 3, 3 to 9. That looks like that works. 7 and 7, 8, 8. 2, 2, 4. I think that's all right. So let's just undo, put the colors back. That was great. I would say that's like 3 out of 5 difficulty at least. That opening was so tricky. That was so cool though with the I keep on wanting to call them perpendicular with the palindrome lines. Making an additional set of the digits 1 to 9, that was very cool, very well designed. And very tricky, very tough to spot that. But it solved so nicely. And the rest of the puzzle was very well put together as well. Like once you got through that, like you didn't need a lot of the stuff, I don't think, to to get through, just to get the idea. Like you only need the thermometer and the palindromes, I think, to illustrate that or to achieve that like full set of the digits 1 to 9ness was just like this much of a palindrome, this much of a palindrome, and that thermometer. But the usage of this German Whisper, and then oh yeah, yeah, then getting the information here, like realizing that these two digits must be the same, which then plugs into those German Whispers, was just, you had a very nice idea, very cool. I mean, I say nice, that seems like it's condescending. A very good idea with the palindromes and the thermometer, and then you just like layered on top the German Whispers so well. It just a wonderful puzzle. Very good job. Thank you for that puzzle micro study, and thank you all for watching.